So, one thing that's just super amazing about software engineering as a career is the fact that you can actually learn all of these things by just having a computer and a stable internet connection. I think that's just one thing that's really amazing is the fact that you don't have to go to college to be a software engineer. You can literally have your computer and a stable internet connection, hop onto Google and just search beginner courses on programming, and that's literally the start of your journey to software engineering. So I thought I should just mention that at the start of this video before I jump into the question that we have for today. So anyway, this is a Leetcode question. It's a medium level question, so it's a bit harder than the ones that we've covered before, but it's called add two numbers. So this is the second question on Leetcode, question number 2. So the problem says that you're given two non-empty linked lists representing two non-negative integers. The digits are sorted in reverse order, and each of their nodes contains only a single digit. Add the two numbers and return the sum of the linked list as a linked list. So you may assume that the two numbers do not contain any leading zero except for the number 0 itself. So remember when we used to do addition back when I was in primary school, we used to start from the right all the way to the left. So we'd do maybe something like 3 plus 4, we'd have that number, and if the number was more than 10, we'd carry 1 on to the next number. Well, in this case, we're just told that this is in reversed order. So essentially, we're starting from the left to the right. So we'll do 2 plus 5, which is what we have right here, 7. 4 plus 6, 10. So it's 0, carry 1. And then we have 1 plus 3 plus 4, which amounts to 8. So that's essentially what this question is asking us to do. But one thing to note is that this is a linked list as well. So it's not any ordinary type of a list. As I mentioned before, I think the previous question that we also had was also on a linked list. So it's a bit different in terms of how we're going to handle it. But that was just a quick overview of the question itself. Now we'll jump into the conceptual overview, take a look at what we mean by sort of handling this question, and then we'll actually jump into the code and implement it. So yeah, let's jump into it. Okay, so I've started out by writing the question in my own words. This is usually the first thing that I do with these questions. So that's what this first comment is up here. So I've said that I'm writing a function that takes in two linked lists representing numbers. So in this case, the number 243 and the number 564. And we're asked to add the two numbers and to return the sum in the form of a linked list. Okay, so this example is the exact one that we had in our problem definition. We have the number 243 and the number 564, and then we have the sum down here. But we are also told that the numbers are in reversed order. So traditionally, we would start the addition from the right side going to the left side. So we'd do 3 plus 4, 4 plus 6, and then 2 plus 5. But in this case, the numbers are in reversed order, which means we're going to start the addition from the left side going towards the right side. So in this case, 2 plus 5 is equals to the 7. 4 plus 6 is equals to 10. So we'll do 0, and then we'll have an additional carry of the number 1. And then lastly, we'll do 1 plus 3 plus 4, which equals to 8. And that's what we return down here. More importantly, we return this in the form of a linked list. So that's what the question specifies. Okay, so I have a couple of steps that I'm just going to paste right here, and then we'll go through them one by one. If I could just format this. Okay, cool. So the first thing that we're going to do is we're going to initialize the final sum and its head. Now the final sum is exactly what we have down here. So it's the final thing that we're going to be returning from the function. It's a product of the two numbers. Now the reason why we have the actual final sum and then we also have the head is because we need to track as we go through each of the operations in the final sum. So that's what the final sum is for. We'll have the number 7, 0, and 8. But in the end, we just want to return this number 7, which is essentially the head of the linked list. And that 7 is going to point to all of these other digits that we're going to need. The next thing that we're going to do is we're going to initialize an addition variable to track any number addition more than 10. So in the case that we do 4 plus 6, right here we can't have the number 10. So we can't have something like this. That's invalid. So we'll have the number 0 and then we'll carry 1, but we need a way to track that 1. So that's what this addition variable will do. The next thing that we're going to do is we're going to loop through each of the operations in these numbers. So from the numbers that we have right here, for each digits we'll have to do the addition operation. So in the first case we'll do 2 plus 5. The second case we'll do 4 plus 6. The third case will be 1 plus 3 plus 4. So we're going to loop while we have a digit that we're essentially looking at. So that's what L1 and L2 is. So in the case that we have 2, the number 2, or we have the number 5, then we're going to do a couple of operations that are going to be within our loop, essentially. And then inside there, we're going to calculate the total sum, which is essentially equal to the digits that we have at the current operation, and then plus any additional number. So in this case, we'll do 2 plus 5. In this case, we'll do 4 plus 6. In this case, we'll do 1, which was addition, plus 3 plus 4, which gives us 8. And then for each operation, we're going to say if the sum is greater than equal to 10, we'll set the addition to 1, and then we'll set the value of the new sum to be the initial sum minus 10. So this is specific to when the additional operation is more than 10. For example, 4 plus 6 is more than 10. So we'll do 0, which is essentially 10 minus 10, which is 0. And then we'll set addition to 1, which is going to be added in the next operation, 1 plus 3 plus 4. The next thing that we're going to do is we're going to update the final sum with the new sum that has been calculated. So the final sum is this right here. We need a way to update this linked list to say that, okay, 2 plus 5 is 7, 4 plus 6 is 10. Then last operation, return this digit 8. So that in the end, we'll be able to return the head, which is going to reference this number, which is essentially the addition between the two numbers that we're provided with. And then lastly, we're going to set L1 to next and L2 to next. This is all while within the loop block, by the way. And what do I mean by this? What I mean is that we need to essentially add for each of the digits that we have in the linked list. So we'll start off the operation with 2 and 5, but we'll need to now compare 4 and 6. But the way that our linked list works is that we're only provided with the first digit, and then the first digit, which is the head, references as the next digit in the linked list. So in order for us to do the operation 4 plus 6, we'll have to set L1 to be now 4, which is 2's next, which is 4, and then L2 to be this 5's next, which is 6. So that in the next operation, we'll now have the digits 4 and 6, and we'll do 4 plus 6. And that's essentially how we go through each of the levels. So 2 plus 5, 4 plus 6, 3 plus 4. And then lastly, we're just going to return the head, or the final sum, which is the number 7, which is going to be the number 7 in this case. And then we'll do, for that head, 7.next would be 0, that.next would be 8. And then we would have returned this product of the addition in the form of a linked list, which is what we need to do as per the question. Okay, so I think I've spoken enough. Let me just jump into the code, and then we're going to implement this real quick. So the first thing that we're going to do is we're going to initialize final sum and its head. So we'll do final sum, and then we'll do head. So we'll just initialize them. And then the next thing that we need to initialize is an addition variable. So we'll say addition, and then I'm going to set it to 0 for now, because essentially there's nothing that we're carrying over. The next thing that we need to do is we need to loop while we have either the list 1 or the list 2. Remember, the list 1 is set to the first digit in the list, and then the list 2 is set to this second digit in the list. So remember, this is what we're provided with. This, in this scenario, amounts to L1 and L2. So what we're going to do is we're just going to say, while we have a list 1 or we have a list 2, and if that's the case, we're going to initialize a sum. So we're going to calculate a sum, the current sum for the operation that's being calculated. So we'll just say that let sum, and then we're going to initialize it to 0 now. And then we're going to say that if there's any additional thing that was there, so if addition is equals to 1, we're going to add that to the current sum. So we'll say that if we have an addition, then we're going to say that the sum is equals to sum plus the addition, which is 1. So take a look at this case where we have 1 carried over from the previous operation. So we'll do that 1 plus 0 before we add it to 3 and 4 to get the final product. And then once we've added that, we're going to set addition back to 0, because essentially we've already added it. Then the next thing that we're going to do is we're going to add the next thing, which is in this case would be 3, if we're looking at this final level right here. So we'll say if we have an L1, because there might be a scenario where we have a shorter list for the first one and a longer list for the second one. In that case, there might be a scenario where L1 isn't really described. So we have to check if it actually exists. So that's just a check that we have to do. And if it does, we're just going to say that the new sum is now equal to sum, which is what we had before. So if we carried on with this first part right here, it would be 1 plus 0. So the sum would be 1 in this case. And then we now add this 3, which would be the L1. So what's important is to note that this is going to be L1.val and not L1. And the reason we're saying .val is because a linked list works in such a way that we have different nodes in the list. And a node is represented by the value, which is the actual digit, and then the next value. So essentially we have something like L1.val, which is 2, and then we have a next variable, which points to the next digit in the list. So this 2's next would be this 4. Okay, so, and then what we have to say is that now that we have already added that digit, we're now going to set it to be the next one, so that in the next operation, we now compare it with 4 plus the operation that would be currently at. So this is essentially moving to the next level, from 2 to 4. And to do that, we're just going to say L1 is equals to L1.next. Pretty easy. And then we'll do the same thing for the second list, which is what we're provided with here. We'll say that if we have an L2, the sum would be equal to the sum. Remember, if we had calculated L1, L1 is already part of the sum. So this is already inclusive of L1, if it was there. So we'll do L2.val, and then we'll say L2 to move it to the next level as well is equals to L2.next. Okay, so now we've essentially done the operation. But remember that there is a case where the sum could be equal to 10 or could be more than 10. In that case, we have to essentially say that we're carrying over 1, and then we set the new sum to be the product of the addition minus 10. So what we're going to say is that if the sum is greater than equal to 10, in that case, we're going to say that the new sum is equal to sum minus 10. So for example, here we'll say that if it's 4 plus 6 is equals to 10, we're going to say that this 0 is essentially 10 minus 10, which is 0. And then we're going to set the addition because we're carrying over 1. And then we're going to say that addition is equals to 1. Okay? And then now after we do that, what we're going to say is that we're going to update the final sum with this new sum that has been calculated. So up to now, we haven't really involved these two variables, and that's what we're going to do. Now, there are two scenarios. There's a first scenario where we have not exactly encountered the first final sum. So we have to actually create it from scratch. And to do that, all we have to do is we check that if we don't have the final sum, we're going to say that, the final sum is equals to a new list node. So that's how we create this thing essentially, because we said that each of the elements represented in the linked list has a dot value and it has a dot next. Now, how do we represent that data structure? We just say that the final sum is equal to a new list node. And then to initialize it with this value, we're now just going to pass in the sum that has been calculated. So we'll say that it's equal to the sum. Now, if we're at the start, we're also going to set the final sum to be, we're going to set the head to be the final sum, because that's what we need to return at the end. So in this case, if we wanted to return 7, we're just going to say that the head is equals to final sum. Okay, so that's in the case that we encountered it the first time. But how about if we're now in the second time? So we already have the final sum. What we're going to do is we're going to say that this final sum dot next is now equals to what we have created there. We'll still have to create a new list node, and we're going to set the next of the final sum to be that new list node. So we'll just do an else block. So if we are not at the start, we're going to say that the final sum dot next is equals to another new list node, and then we're going to pass in the sum again. And then now this other step is very important because we have to move from here to the next level, which is essentially what we just created, so that in the next operation, we're going to set that to be the next to be essentially, then this 8 will be the next of this 0. If we do not do this line, which is final sum is equals to final sum dot next, if we don't move from this 7 to this 0, if we get to this operation, which is 1 plus 3 plus 4, which is this 8, we'll set this next to be this 8. In that case, we'll have something like this, 7, 8. We'll essentially have overwritten this 0. That's why this is very important. We need to move from this 7 to essentially what we have created, so that in the next operation, we're going to say that that current dot next is equals to now the new calculation that we'll have there. Okay, so I know that that was a bit, but after we have completed all of the steps, finally what we just have to do is to return the head. Okay, and that's pretty much it. But remember that there is one edge case that we haven't covered, and that's in the case that maybe at the end, let's say that we have something like this. We have 6. So 4 plus 6 would be 10. We have an additional 1. But now 1 plus 6 plus 4 is 11. So now what happens to that 1 that we had added there? This wouldn't be the answer. The answer would be 0, would be 7, 0, 1, and then another 1. So to cover this edge case, all that we have to do before we return the head is we check that if we have an addition. And if we have an addition, we're going to say that final sum dot next. Remember that if we are at the end, the final sum would be this 1. So now we're saying that this 1 dot next is equals to the addition that we just did for that operation. So we'll say final sum dot next is equals to a new list node again, and then we're going to pass in this addition right there. And that's pretty much it. Pretty simple. That's been how to solve this problem. I'm now going to essentially copy this code onto Leetcode and see if it works. Fingers crossed.